How are you, my friends? In this video, I'm presenting lecture number 8 of the pre-calculus course. So this lecture is about logarithmic equations. Just to remind you, please, you can review lecture number 7 on exponential equations. And at the end of this lecture 8, you can find all the exams questions to practice on both lectures 7 and 8. Now, logarithmic equation is one in which a logarithm of the variable occurs. So we have log of something in the equation. Now there's one-to-one property here. We says if we have log base a of x is equal log base a of y, and we have the same base, then argument 1 here is equal argument 2. So x is equal to y. Remember the conditions. X should be positive, y should be positive because these are arguments. The base a should be positive and a cannot be 1. There are 3 nice important guidelines for solving logarithmic equations. You can use the properties anytime in the questions. You can use laws of logarithms. You can use LE rule, where we change from log to exponential and vice versa. You must check in the original equation. When you get the x, it's not enough to leave the answer as exponential equations, because here we have to make sure that the argument should be positive. Just to refresh your memory here, this is the properties of the logarithms. This is pre-calculus course lecture number 5. You can go and review if you want. Lecture number 5, there are 4 properties. And also we have 3 laws: the product and the quotient and the power. This is pre-calculus course lecture number 6. Now let's start example 8. Because we have 7 examples there in the exponential equations. We have log base 2 of this, x cubed minus 19 is equal to 3. And here we have equation not ready. So this one we call it ready equation. Let's see. So this is a ready equation because we have 1 log of an argument is equal a number. So I can use LE rule. See, the y here is 3, log base a here is the 2, x, see the argument here, x is all this, x cubed minus 19. See, in the LE rule, logarithmic exponential rule, x, which is x cubed minus 19, is equal a, the base 2 to the power y, 3. So x cubed will be here, 2 power 3 is 8. So x cubed will be 27. Take the cube root of both sides, x will be 3. Just to make sure, if you put 3 in the original equation, the argument here becomes positive. So the solution set is only 3. Now, the second one here, not ready. So you have to take 4 on the other side. You have to divide by 3. You have to do some work. So rearrange it first. So take 4 on the other side, becomes here 12. Divide by 3 becomes 4, ln of 2x. So I can use LE rule now. 2x, see 2x, the base here is e. See, ln, the base is e to the power 4. Divide by 2, so x will be e to the power 4 divided by 2. That's the answer. Sorry. Let's find the sum of all the solutions of this equation. We have log of something minus log of something is equal log of something. This is base 10. So I can use the laws. See the quotient here? Log of u. Remember, this is log of u minus log of v becomes log of u over v is equal log of x plus 4. Then I can use one-to-one property. We have the same base, so I can take this one. The argument 1 is equal to the argument 2. See, x, 6 minus x over x is equal to x plus 4. Now we cross multiply and find x. You see the idea how to do that? You have to make sure one-to-one property is 1 log on each side with another different arguments. So when you cross, this is the original equation. We need it at the end. So cross multiply here, we get 6 minus x is equal to x squared plus 4x, rearrange it, you get quadratic equation, factor it, x minus 1, x plus 6, and then x will be 1 or minus 6. Now we cannot take these answers unless we check them. Any number can be rejected or accepted, positive or negative. So this one, I take the first number 1 in the original equation. You see, log of 6 minus 1 minus log of 1, 1 plus 4. I have to make sure all these arguments are positive. No, look here. If I put minus 6 there, see in the x here, this is okay here, first one. 6 minus minus x, that's 12. But here I have one argument here is negative. If I have one argument negative, I cannot accept the whole number. See, this is all minus 6 is rejected. So the solution set only 1. If I say find the sum, it's only 1. You cannot add these two. Now let's find here the product of all the solutions of the logarithmic equation. We can see here base 5, base 25, and here base 5. So for sure we have to change the base. Now here we need to change the base of the second term from 25 to 5. So I can use the change of base formula I put here. Log base 5 of 3 minus x squared divided by log base 5 of 25. 25 becomes 5 squared. So 2 comes down, and here from the power 2 comes down. When you cancel, you get log base 5 of 3 minus x. That's in the second term. So now the equation becomes log base 5 of minus x plus log base 5 of 3 minus x is equal to that one. I can use the product here backwards. See the laws of the logarithms. So I can multiply minus x times 3 minus x, and we have the same base. And I can take the power here, 2. 2 squared becomes 4. Then I use the one-to-one property. So minus x multiplied with 3 minus x with minus x plus x squared is equal to 4. So this is an equation. Rearrange it, factor it, find the solution. So we have x squared minus 3x minus 4 is equal to 0. We factor it, x plus 1, x minus 4. As I mentioned before, any solution you get from logarithmic equation, any solution, you have to check it in the original equation, negative or positive. Anyone can be rejected or can be accepted. In this case, if I put minus 1 there, minus 1, see, this is accepted. If I put 4, although 4 is positive, so minus times the 4. See, log, the argument here negative, minus 4. So 4 is rejected. So the solution set is minus 1. I'm asking for the product. The product will be only minus 1. Find the number of solutions of this logarithmic equation. We have log base 7 of x minus 51 minus log base 7 of 1 minus x is equal to 2. Let's find the number of solutions. So we have to solve it, see how many solutions, and then we count them. We say 2 solutions, 1 solution, 3 solutions, etc. Now I can use the laws of logarithm on the left. So this is a minus, becomes a division. So log base 7, x minus 51 over 1 minus x is equal to 2. I can use the LE rule. So directly I take the argument here. X minus 51 over 1 minus x is equal the base 7 squared, which is 49. Cross multiply, I get x is equal to 2. I have to check. See, if I put 2 here, 1 minus 2. Also 2 here, 2 minus 51. The argument is negative. Anywhere, see 1 minus 2. 2 minus 51. If you put it anywhere, the argument is negative. Then reject it. And this is the only solution we get, x equals 2. So no solution. Now the question says find the number of solutions is 0. Now, question number 12 says, find the point or points of intersection of the graphs of the functions f and g. Now, we notice here base 3 in the function f and here base 1 over 3. So it's a good idea that we change the base here from 1 over 3 to 3. I will show you now how to change the base on the function g. By using the change of base formula, this becomes log base 3 of 4 minus x over log base 3 of 1 over 3. So this becomes 3 power minus 1. So there's a minus 1 here, so it will be on the line. So now we have function g, 1 minus log base 3 of 4 minus x. Now, if we need point or points of intersection, I can take y is equal to y. That means f of x is equal to g of x. Because the points in the intersection, the same y, same x. So I can start with the same y. I put the function f is log base 3 of 2 minus x, log base g 1 minus, log base 3 of 4 minus x. Then I can solve the equation now. So this is lecture number 8, solving logarithmic equations. So this one becomes on the other side is equal to 1. Use the laws of logarithm. So this becomes product. See this one here, product backwards. So log base 3 of 2 minus x times 4 minus x. When you multiply them and rearrange the equation, you get x squared. Please, you can check all these numbers. X squared minus 6x plus 5 is equal to 0. Factor it. There are two solutions, x equals 1 or x equals 5. Both are positive. But as I mentioned before, many times, you have to check each solution in the logarithmic equations. 5 will be rejected because 4 minus 5 here makes it negative, 2 minus 5 makes it negative, and then the only solution is x equals 1. So the point of intersection, 1 and 0. How do we know 0? I put 1 in the function f here. I put 1 in the function g. Either one, I will get the same number here. So 1, 0 is the point of intersection. It can be any other number. It can be 1, 7 or 1 minus 2 or 1 half. It happened here. It is 1 and 0. Now let's solve another logarithmic equation. We have ln of x minus 1 plus ln of x plus 2 is equal to 1. Here we can use the laws backward. So you multiply because we have a plus here. So we multiply log of x minus 1, x plus 2 in the product is equal to 1. I can use the LE rule. So I can take the big argument here. See this x, which is x minus 1 times x plus 2 is equal to the base e. Here is the base a, the base e to the power 1. So when I multiply, I get x squared plus, see here, 2x minus 1x becomes plus x minus 2, and then I bring the e, minus e is equal to 0. So this is a quadratic equation, not easy. We cannot factor it for sure, because a here is 1, b is also 1, but c is minus 2 minus e. So I have to use the quadratic formula. You know, this is the quadratic formula. I put a1, b1, c minus 2 minus e. I get the answer here, two solutions. I have to check, make sure the argument should be positive. Now here I will leave for you some old exam questions. Let's say question number 1, given the equation 125 to the power x plus 5 to the power 3x plus 1 is equal 48. If you use log of 2, which is base 10, is equal to k, find x. So x will be multiple choice here, A, B, C, D, E. Please check that one. Question number 2, we have 5 to the power 2x plus 1 is equal 10 to the power 1 plus x. If I give you log, base 10 here, log of 5 is equal to b. Find x in terms of b. Now you find the sum of all the solutions of this exponential equations. I put here the sum in the answers, A, B, C, D, also multiple choice. Find all the solutions and then add them. If the sum of the solutions of this equation, 1 plus 5 to the power 2x divided by minus 1 plus 5 to the power minus 2x is equal minus 6. If the sum is this one here, log base a of square root of b, find a times b. Now question number 5 is find the point or points of intersection of the graphs of the functions f and g. So try that, please. And then question number 6, the sum of all the solutions of this logarithmic equation is given is a, b, c, d, multiple choice. Here we have base 10 log of 2x minus 1 is equal log base 10 also 4x minus 5 plus log base 1 over 10 of x minus 1. So the idea here is to change the base here to 10, then you can proceed. Question number 7, we need to find the product of all the solutions of this equation base 2, and then find the sum of all the solutions of this logarithmic equation, ln of e to the power ln of x minus ln of x squared minus 3 is equal ln of 2. Now here are all the answers for the 8 questions, the final answer. For complete solution, please, of these questions, you can see the video on exponential and logarithmic equations, lectures 7 and 8, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture number 8 of pre-calculus course. I wish I can see you in another lecture, another topic, another time. Thank you very much.